Hello guys, I'm back again with another live stream. Um, for now my camera is not working. I don't know why. I was trying to fix it, but I'll I'll try to fix it in my break time. Okay, so we are back again with another live stream. Um, I think I'm sorry for the last stream because my internet went down and was not able to complete the stream last time. So no problem. I'm here. We are live again, and let's do it. Let's do today some coding questions. So so today I'm thinking of trying to solve some uh, simple medium level of question from lead code. I'll start from one or two medium level of lead code, and then we'll jump to hard level of lead code. And if everything goes well, we can go to code forces also, and we'll try to solve some code forces questions also. So so yeah, this is our my plan for today. And yeah, so I'll be explaining all the questions. So if you want to listen, uh, if you want to solve with me, let's stick together and let's solve these questions together. So it'll be really fun to watch the stream and to be present with me and everything. Yeah, let's do it. Let's do it. We can do it. Yeah. So let's tag something. Start. Let me open my Pomodoro. Pomo focus. I'll start. It's simple. We always we used to do. We'll take 50 minutes of and no, we can only do one. Okay, any tag will work. So we have a maximum gap. Let's pick this one. So we'll do 50 minutes of study, and then we'll take a 10 minutes of break, and in that 10 minutes of break I'll try to fix my camera. I don't know what happened to my camera. It's fine then, no issues. Okay. Seriously, I returned one over here. Why? Just to check, I think. Okay. So it's saying that we are given an integer array nums. Return the maximum difference between two successive elements in its sorted form. If the array contains less than two elements, return 0. Okay. So it is saying given an integer array norms, return the maximum difference between two successive elements in its sorted form. If the array contains less than two elements, return 0. That runs in linear time and uses linear extra space. Okay, so it is saying I need to write an algorithm in something linear time, and I should use only linear extra space and not more than that. And the question is something, if we sort this array, we'll get something like this, and I need the maximum difference between them. So 3 minus 1 will give me 2, 6 minus 3 will give me 3, and 9 minus 6 will give me 3. So the maximum is 3. Any of one of them can be picked. So the maximum is 3. I need to return that maximum. And I do not have to sort the array because it will take n log n time complexity. It will be easier for me to sort the array and return the answer. So it's not like that. So I can take extra space, that is what it is saying. So it's possible for me to take extra space but not extra time. Yeah, that's why it is in medium, else it would have been in easy level. Just sort it and find the maximum difference. How can we do it? Okay, so we are given 3691. Let's build our intuition. What we can do, we are given that I can use some extra space. If possible, I can use some extra space. That too should be linear. I should not use like two extra space or n square or something like that. Okay. So 3691. What can we do here? So is it possible to find just larger element than this value? Next greater element for every uh, array, for every number. If I find the next greater element is nothing. For 3, it's 6. For 6, it's 9. For 9, there's no next greater element. For 1, it's 3. But this is something very obvious. If I do 3, 1, 9 and 6, now I need to find the next greater element. So next greater element for 3 is nothing but 6, not 9. So somehow if I able to find the next greater element of each of the way number of each number, will be able to do it. So the next greater element for 3 is 6, correct. So for 1 it's 9, for 1 it's 3. Okay. So if I consider 3, I have 3, next is 1, next is 9. 9 is one of the possibility that it is greater than 1. So we have 4 blank over here. If 9 arrives, 9 is at index 0, 1, 2, 3, 1 and 0. So for 1, 9 could be one of the possible answer, one of the greater element. Could be, but not for sure it will be. Hmm. We have 6 and 9. Hmm. If we do the same thing twice, we'll be able to find something. You see 3. Again 9 will come, and again this 2 will be removed. I don't want. This 9 will remove these whole 3. Hmm. Tricky, huh? Need to know just greater element for each of the element. I don't want next greater element. I need to know just greater element. What can we do for just greater element? No, this is next greater element. This won't. I don't want this next. What does this mean? Given two arrays A and B containing n element, the task is to find for every element in the array BFI the element which is just strictly greater than the element which is. See, n log n is not something what I want. I have 3, I keep 3. I won't. What is this bucket sort and radix sort? So this is something specific related to counting sort and radix sort. Okay, something related to radix sort or bucket sort. Um, which isn't actually specific algorithm related. let's start with something which I at least can be solved. This was one of the question from recent contest, I suppose. Let's try this one. So we are given a string s of length n and an integer k. So we are given a string of length s, which is nothing but a b c d and an integer k, where n is a multiple of k. Okay, it should be a multiple of k. One means 2, 4, 8, 6, 2, 4, 8, 10, 6 also. Your task is to hash the string s into a new string called result, which has a length of n by k. Means 4 divided by 2. That should be a length of 2. Okay. First divide into n by k substring, each with length k. But first divide s into n by k substrings, each with length k. Then initialize result in an empty string for each substring in order from the beginning. Hash values of character is the index of that character in the English alphabet. Calculate the sum of all the hash values of the characters in the substring. Find the remainder of their sum when divided by 26, which is called hashed char. Identify the character in the English lowercase alphabet that correspond to the hashed char. Append that character to the end of the result. Okay. So it looks very ugly, but I think it should not be that much ugly. So it is saying divide it into k part, so a, b and c, d. So a has a value of 0, b has a value of 1, c has a value of 2 and 3. So sum it up. After summing we'll get 1, modulo it with 26, which will give me remainder as 1, and 1 is nothing but b. For this, adding this will give me 5. 5 modulo 26 will give me 5 again. 5 is nothing but f, so it's bf. So it's not that difficult. M, x, z, I'll take 3. M value is 12, x is 23 and z is 24. Sorry, y is 24, z is 25, which sums up to 60, and moduling it with 26 will give me 8, which is nothing but I. So it's not that hard, simple, straightforward solution. Okay, so let's solve. Let's declare a variable which will start while I is lesser than s dot size. We will continue. Now what specifically we will do is we need to iterate k times each string. So uh, 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 Times is equals to k while times, because it will be multiple. It's saying while times minus minus, so 3 2 1, and after that 0. So okay, fine. So what, while times is minus minus, this means I'm iterating 3 times or 4 times, whatever the k value is. And then we need someone to keep its value. So keeping its value in short integer might give me an integer overflow. And also I need a string answer or result initially initialized as empty. So times, what I will do, I'll add in my sum is equals to um, sum is equals to s of I minus a. That will add some value and then I'll increase my I. And after summing it up, I need to modulo it with 26. So result is equals to result plus times sum modulo 26 will give me something, and in that I'll add a. Why you want me to place it in some I character or something? So it's accepted. Yeah, this was not that difficult, it was pretty straightforward. Hash divided string. Count almost equal pairs 1. Okay, let's see what is given. You are given an array nums consisting of positive integers. We call two integers x and y in this problem almost equal if both integer can become equal after performing the following operation at most once. Choose either x or y and swap any two digits within the chosen number. Return the number of indices I and j in nums where I is lesser than j such that nums of I and nums of j are almost equal. Note that is allowed for an integer to have leading zeros after performing an operation. You are given an array nums consisting of positive integers. We call two integer x and y in this problem almost equal if both integers can become equal after performing the following operation at most once. Okay, so what is the operation that we are performing? Uh, Choose either x or y and swap any two digits within the chosen number. Digits, okay, I have to swap digits. So if we swap the digits, it will become almost equal. Return the number of indices I and j in nums. How to for an integer to have leading zeros after performing an operation. Okay, I have to swap the digits within. So it is saying 3, 12, 30, 17, 21. Mm, in this case 1, 2, 3. If I sort this as 1, 2, 3 again. I know that they both will become equal. Mm, 1 3 2 3. So I know by watching here I can say that there are different numbers. 2 is um, see, I need to do that operation only once, at most once, not more than that, right? So somehow I need to know like how many digits are different with each other. Hmm. If somehow I get to know how many swaps will be required. See, 2 is not compared with 1. I need 1 swap, that's for sure. With someone, with some other. Because after sorting, I know that they both are equal. 2 is not compared with 3. 3 is not compared with 1. So we need total of 3 changes over here. If we require 3 changes, that means we won't be able to do it. There would have been one character same so that I can do this operation, because I need to do this at most once. So what I am thinking right now is somehow, if somehow mm, I have 3 and I should keep this in sorted. So I have 12. 12 is already sorted and I'll keep it. Now comes 30. I'll sort this. It will be 0 3, which is nothing but 3, and sorry. Hmm. One thing that we can do is initially make all the digits of same length. Maybe I'll make everything of length 6, 6, because 6 is the maximum length that we can have. So it'll be easier for me to solve it. So I'll add zeros at 5 and 3. 0 0 0 1 2 0 3 0. Now everything, one has 6 digits. I'll make some kind of hash map. Zero 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 1 2. Now 3 0. If we sort this, it will be 0 0 0 0 0 3. Right. And it is matching with something. Hmm. That means if it is matching, there is a possibility. Hmm. What's the index? What all positions do we have? Might be possible there are multiple positions where this number is occurring. Then we'll have to go at every position and compare it, whether how many changes do we need for this, because its length is nums dot length is 100. We can clearly use some space. How many? Right. I think this should work. And after sorting it, I'll keep this also. Like this was at 0, this was at 1, this was at 2, this was at 3, this was at 4. Okay. Uh, Also, if we sort this, we'll get 0 0 0 0 1 2. So they should be independent. If what will happen, there is 3 3 0. What instead of 3 0 we have 300. Sorting will obviously give me 0 0 3. I'm comparing it with 3. So what can we do in this case? I need to have someone who will tell me what was the length. I'll add extra for the length. I'll keep a track of length also. That will help. Hmm. So we'll keep this sorted array. We'll keep its indexes. But There'll be some issue. This length will make it different. I need to keep track this of this length somewhere else. Maybe in the key and value pair. Keep the index and its length. Yeah, then index and its length. Then index and its length. We can do something like that. Yeah, maybe I'll try with that. Let's see if it is working or not. So I'll use this concept. I'll keep a sorted array and keep the indices list. Sorted array indices list. Sorted array indices list. Indices list will contain some values. Okay. Okay. Fine. Let's take a 10-minute of break, and after break, I'll be back and I'll try to solve this question with the logic that I have written. So okay, I'll be back in 10 minutes. Hello. Um, Back. Okay. We were at discussion. I think the approach that we were thinking is might work and might not work, but it's very lengthy kind of approach. I'll just take some hint. Small, you can check all pairs in the array. Yeah, obviously I'll go with n square and I'll check with all pairs. I need to know what will be the output if three are same. Um, just in case if I add one more 30 over here, what will happen? Earlier we used to get 2, now will it be 3, or we are removing that pair directly? Oh. So we have a total pair of 4. Okay. How 4? 30 with 3 1 pair, 30 with 3 2 pair, 30 with 33 pair. Okay, all the pairs. We are not removing that pair. We are still considering that pair. Instead of going these many changes, let's simply do what? Let's go for a n square loop. Here select this character. I want someone whose length is maximum. The length can be 2, or it can be same, or it can be 2. That's the maximum that it can be, right? We were doing so much confusing things earlier, but I don't think we require those many things. So maybe the maximum length that we can have is 2 difference between the length, and if it is even if it is one more, then there should be a 0, like if the difference and like case something that we got, if the difference uh, between two number is more than 0, if it is more than 0 or equals to 1, equals to 1, suppose equals to 1, that means there should be a 0 extra and rest of the characters should be same. So the extra character must be a 0, because that and that extra character has some specific position, don't you think so? Some specific position it will have. What extra character that we have has some specific position. The specific position will be obviously at the beginning, and whatever character is at the beginning, I'll swap it with that character. Correct. Now suppose let's deep dive a little more to 132 and 05, and there is a character 3215. Now if they both will match only in the case when 0 and 1 are swapped, because this 0 will have no meaning when it is swapped over here. So the rest of the character will match with this. If this would have not been the case, 32105 something like this, then it will never match. So there is only one case, if the length is more, then we need to swap it. And after swapping, if the array becomes, it does not become equal, uh, swapping, um, if the array does do not become equal, I'll simply say that it did not match. And if they are equal, and if suppose the lengths are equal, then we need to check. Now if lengths are equal, then we only need to check like how many characters are not matching. If it is more than, then character not matching is more than 2, then not possible. It should be equal to 2, or can it be 1? Okay, so let's with this intuition, let's try to solve this. Let's try to solve this and see if it is possible for us to make it or not. Okay, so what we were thinking of, will be creating two for loops. Int I is equals to 0, I is lesser than nums dot size plus plus I, and for j is equals to I plus 1, I'll start from and go till nums plus plus j. Fine. Now these are the two elements, int le1, which is nothing but nums of I, le2, which is nothing but nums of j. Correct. So this is my element 2. Now this element 1, I need it to keep, I need this to be kept somewhere. I need this to be in array vector int nums1 while while element 1 is there, I'll pick the last element. Last element will be nothing but element 1 modulo 10, and element 1 divided by 10. So the last element will be pushed in my nums 1 dot push back lastly. Okay, now I need to reverse this 1 dot nums 1 dot begin comma nums 1 dot end. So this will give me what? This will give me the 3 or if we are taking 1 2, then it will give me 1 2, not 2 1, because I'm reversing it. Fine, now the same thing I need over here with nums 2 element 2 last element 2 element 2 element 2 nums 2 and last element. So this will do what? This will create nums 1 and nums 2 separate. Now I need to compare these two. Now if nums 1 dot size see absolute difference, if my nums 1 size is greater than nums 2 dot size, then it will never be possible to match it. Should be nums 2 dot size should be greater than. So if nums 1 dot size means nums 2 dot size minus nums 1 dot size is equals to 1, that means there is a difference. Now there is something I need to be careful of. This will do some, so this will create one problem, is that if there is 2 zeros, so which 0 should be followed up, like so if something like this, so in this case this 0 should be swapped up, but if I add but if I add 1 over here and a 0 over here, 1 2 3 4 5 6, so this in this case this 0 should be swapped, right? So this will create a problem. This case needs to be handled if the difference is 1. That means what? That means should be compared something. If I skip the first element, because I know this element should be different. Element 0 should be 0 different with 0 element, then only possible. If they both are same, so we cannot add a 0 over here, and this will never contain 0. Okay, so one thing, condition, if nums of 2 of 0 is equals to nums of 1 of 0, that means I can't do anything. This won't be considered in our answer. If they are different, then we can add a 0 over here. Now if we add a 0 over here, suppose, now from starting from this element, I'll start to compare this. 3 matching, 2 matching, 0 matching, 5 matching. There is one which is not matching, which can be swapped with this. Now if same case happens, then 1 is here, so 3 is matching, 2 is matching, these two are not matching, and 2 3 4 5, 1 2 3 4, 1 2 3 4 5 6 8 6, I don't, maybe I'll remove this one. So this is matching, 5 and 1 is not matching. And 1 and 5 is not matching, and 5 and 0 is not matching. So there are two elements which are not matching. Means I need to find a position where they are not matching. All the positions where they are not matching. If it is greater than 1, because I already know that these elements are not matching, so I need only one. So for int int k will start from index 1. And also one thing that I need to be sure of, position m will start with 0, m will go till nums 1 dot size plus m. Now if nums 1 of m is not equals to nums 2 of k, then count plus and position will be updated with should I update it with k or should I update it with m? Anything will, let's update it with m. Now if count is greater than 1 or count is equals to 0, then that means not possible. And if it is 1, I need to check after swapping that position with 0 array is matching or not. No, that position should be no one thing. If it is 1, so if nums 2 of k is not equals to 0, then also continue, because that should be 0. And if it is 0, if it is 0, so the nums of nums 2 of 0 should match with the position that I want to swap to. Now the condition will only be if nums 1 of k minus position, sorry, if nums 1 of position minus 1 is equals to nums 2 of position, then count plus plus. Result is equals to 0. And in any of the other cases, because 0 1 2 3. Now nums 1 of this should match with nums 2 of 0. If that is the case, then we will increase. This was the case when difference is 1. Now else if nums 1 dot size is equals to nums 2 dot size, if both of them have the same size, if both of them will have the same size, that means I need to check how many are not matching. So I'll simply go over this for loop. Anything will work. Nums1 dot size plus m. Now if I'll declare a count and if nums 1 of m I need to know the position 1 and position 2 and position 1. If nums 1 of m is equals to not equals to nums 2 of m, if they are not equals, that means we can do something. If position 1 is equals to negative 1, then position 1 is equals to m. Else if position 2 is equals to negative 1, so position 2 will be equals to m, and count will always increase if they are not matching. After this for loop, if count is more than 2, if count is equals to 2, then swapping any of them, so there is a swap method. I don't remember the swap method. nums 2 का पोजीशन 1 रख लो इसमें, फिर nums 2 position 1 should be updated with nums 2 of position 2 and nums 2 of position 2 should be nums 1 is equal to this. Okay, let's see. Output is only 1. Case 1 only 2. Which 2 is coming? These 30 is one which is coming, and now if 3 and 30, let's take 3 and 30, only 3 and 30. So 3 and 30 do not match. Okay, why is that so? Let's see if I element reverse. Yes, bro, my webcam is not working properly. I'll see it in the lunch break. That why it is not working. I why so much addicted to one eye? Why this 30-30 twice? That is because of this. So we got 3 and 30. So the number is correct that we got. So nums2 dot size. So nums2 dot size is minus nums1 dot size is equals to 1, which is true. So it'll go here. See, they were matching and I continued. So that will create a problem. 30 and 300 will should have been matched. And it's when the difference is when we are having some problem. When the difference is not one, it's very simple. When there is a difference, this if condition inside this, if I need to somehow handle things more properly, what can we do if we know that 30 and 300 is there? And you know one thing, 30 and this 3000 will also match. 30 and 3000 will also match, because if we swap this 0 with 3, it will become something like this, which is nothing but 30. It's something whose difference is more than 1. There are lots of small cases. How are we handling these things? Uh, so I have these two integers x and y. I'm checking all most equal for these two integers. I have string. I made that integer into a string 1 and a string 2. Fine, that's fine enough. I'm iterating till the maximum length. Make the make the length of two strings equal by adding 0. Uh, Obviously, I was thinking of doing this at first, making the length equal by adding zeros in the front. So this is what he did. He added zeros in the front. Now they are equal. Now he is doing something very simple with the use of two maps. And what is that? He declared two map mp1 and mp2. If the characters is not same, obviously if the characters of the both is not same, in that case we need to do something. So so it will increase my difference as from 0 to 1 because the characters are not same. And what he did is, in map 1 he kept s1 of I plus plus, map 2 he kept s2 of I plus plus. And at last he's saying that if difference is lesser than or equals to 2 and both map are same, both map are same, see the numbers, the elements to be same, or the map should be same, everything inside the map should be same. So for 30 and 3000, he obviously 30 for 30 and 3000 he added 2 extra zeros over here, and now the map will be same because the count of the value is same. The only thing is if the difference between them, so 30 and 1 2 3 4, 4 5 1 2 3 4 5. Now this is what I'm comparing. They do not match. They match, they do not match. 2, they matched. What if it is 1? Lesser than but why? It's like 30, I'm comparing it with 0. So I added 0 over here. 30 0 0 0. Now their difference is not 1. But the map is not same. You see? What is the case when difference is 1? Map is same and difference is 1. Is it even possible that the map is same and difference is 1? No. It should be equals to 2 only. This is how we approached, how we reached to this conclusion. Always if always compare two numbers. This is one thing that I should follow maximum of the time. If we are comparing two numbers, always try to make it of same length. I was making it of same length, but I was doing some complex. I was doing some complex things. Yeah, make it of same length. So and result is equals to 0. result plus is equals to almost q. It should be nums of I and nums of j. I need if I need to compare it, I need to somehow find a solution. Just give me a minute. Just give me a minute. Yeah, I'm back. So we have this maximum length. Now I need to make sure while s1 dot size is not equals to max length, s1 is equals to 0 plus s1, while s2 dot size is not equals to max length, so s2 is equals to 0 plus s2. is this working or it will throw error? Yeah. Yeah. What? It is working. So at last I'll return result, and I is lesser than s, so 1 dot. Now if s1 of I is not equals to s2 of I, then difference plus plus, and I need to declare two map, unordered map, character and integer m1 comma m2, which will make sure m1 of s1 of m2 of s2 of I plus plus. Now return if diff is equals to 2 and m1 is equals to m2. Mm. Oh, okay. I am getting 10. I'm missing. What? Oh, difference is why he added lesser than equals to 2. Now I know if the difference is 0. So for that only means there will be two things. If it is equals to 2, or if difference is equals to 0, means there is no difference, then return 1, means everything matched. Or if everything do not match, then it should be 2, because there will be there will never going to be 1, right? Okay, so this was actual nice question. What I understood from here is always make the length same, not make it different, because that will complicate things. That will always complicate things. Fine. Let's take a 10 minutes of break, and after break I'll be back and we'll solve more questions. My camera is also working. So this was actually a good question, which is nothing but almost equal. Just a second, I'll be back. I need my water bottle. I left it in my kitchen. Yes, I am back. Now it's the webcam is working, Saurabh. You can check. Okay, let's go to the next question. Maximum energy boost from two drinks. So what it is saying that we are given two integer array energy drink A and energy drink B of same length n by a futuristic sport sign test. These array represent the energy boost per hour provided by two different energy drinks A and B. Okay. Okay. Two different energy drinks are giving me this energy and this energy per hour. Okay. For 1 hour, 2 hour, 3 hour. First hour, second hour, third hour. Drinking one energy drink per hour. However, if you want to switch from consuming one energy drink to other, you need to wait for 1 hour to cleanse your system, meaning you won't get energy. You won't get any energy boost in that hour. Okay, the maximum total energy boost you can gain in the next n hours. So in the first is the first time that we are taking, so we can take this energy drink. So in second hour I won't be able to take any of them, and in third hour I can take one. Simple. Or take a one. Okay, I brought some millet cones, ragi chips to eat. Where is my pen? Oh. What happened to my keyboard? No, it's okay. So I think like by seeing this, I have two choices. Either take whole energy drink A or whole energy drink B, or combine both. Either take A or B or something like that. In this case, I took an energy drink of 4 from this. Now, if I wait for an hour and take this energy drink, which will nothing will give me 4 plus 3, that is 7. Hmm. So there are few things that needs to be handled. So suppose at first, this is the first drink that I'm going to drink, so I can drink either energy drink A or energy drink B. I have two choices: drink energy drink 1 or energy drink B. So if I drink energy drink 1, which is nothing but 4, there will be path to drink from the same energy drink in the next hour. So this is 0th index, so I can directly jump to 1. See, skipping this and drinking this is not going to give me an optimal answer always. So either I can drink with the same energy drink, drink A with index 1, or go with drink B with index 2. Now from these two places, whatever we will maximum will get will be added in energy drink A. See, it's kind of looking something like a recursive problem with memorization, that means a DP. So we have this energy drink A, we have this energy drink B, and we will start from index 0. If index is 0 is the It's the only place where we don't have any energy drink. Uh, and nums 2, and I need to have something as previous choice. Previous drink, which drink I took. Okay, so now is previous drink is equals to 0. That means this is the first time I am going to drink anything, any drink. So either I can drink from the first uh, drink, or we can drink from the second drink also. Max energy is nothing but 0 initially. So let's drink from drink 1. So if we drink from position drink 1, so I'll have max of energy and maximum of I'm taking energy drink 1. Just a second. If I am selecting energy drink 1, so select an sorry, excuse me. So if I'm selecting energy drink 1, uh, we will get something max of nums of 1 of idx plus max energy of, see, if I'm selecting drink 1 and I'm jumping to drink 1 only, so then I can go with the next index, and previous drink is 1. I'm selecting drink 1, or if I'm selecting drink 2, no, I'm selecting drink 1. But the next drink which I want is IDX2. So nums 1, nums 2. So next drink will nothing but so from these two cases, whatever we will get, we will compare it with my energy that we have while selecting drink 1. Now select drink 2. Everything from here till here will be same. The only difference will be nums 2 of IDX and nums 2 of IDX. And if I'm selecting energy drink 2, that means I'm going with energy drink 2 only, and with the next index also. And if I'm selecting energy drink 2 and I am going with energy drink 1, so now if previous drink, else if previous drink is equals to 1, that means I want to drink from nums 1. So energy will be equals to maximum of where are you, maximum of energy, or so if previous drink was 1, no, I want to drink the previous this is not showing my previous drink actually. This is showing my current drink. What should I drink? If I'm making it as 1, that means my current drink will be from nums of 1. So this will be the case over here. So nums of IDX, current drink is nums of IDX 1, and next if I'm doing the same drink, or if I'm going with the next drink. So and else let's see if it is working for small cases. Okay, so for the first we are getting 5, and the first second we are getting 7. So these are the maximum energy that we got. Now we need to memoize it, correct? So for memoizing we need a 2D vector int dp. So It will be of size, any one of them. Energy drink A dot size, and the obviously we are keeping long, so sorry, my bad. Long energy drink B. For energy drink B, we had now if dp of idx, this is actually current drink. I'm sorry if you are thinking that this is a previous drink. It's not equals to 0, it's not equals to -1. Return this. Let's see. I'm not passing dp. Everywhere I need to pass dp. Pass dp. dp copy. Pass dp. Pass dp. Pass dp. Pass dp. Pass dp. Okay, so this got accepted. So this was the only thing that we need to be careful of. Initially, if my previous, this is not previous drink, man. Let's change it to current drink now. Find and replace. Is there no find and replace? You are current drink. Current drink. Current drink. Current drink. Current drink. Is it fine? No. Current drink. Fine then. So okay, so this was good question. Is there any other solution than this? Is there any greedy? dp of one space, constant space? Seriously, how? Okay, so I solved it like this. A longer way, always a long way. How he solved it? This is very easy, I suppose. So we have is a0 a1 b0 b1. What's the intuition? AFI means maximum energy in I plus 1 hours, that is 1 hour, okay, hours, ending with A. Okay, I'm making sure ending with A. That means ki, that means what, the last energy drink is A. I'm considering the last energy drink as A, and drink, and then drinking that drinking that energy drink. Uh, that means to drink this energy, because I am drinking this energy only, and I'm considering uh, previous energy as this energy only. So drink up from previous plus this, or and B of I, B of I minus 1, if I'm not drinking this energy. Mm, I'm ending with, let's try it once. I think this is very good. So we have a case of, let's take the second case. 411 113. Suppose initially it's 0 0, and I'm starting from here. Mm-mm. So I'm ending with energy drink 1. uh, I want to end with an, if I'm drinking this energy drink, so I can drink previous energy drink as well of this same energy drink. So 4 plus 0 will give me 4. Or if I'm if I'm drinking this energy drink, so previously I would have skipped one energy drink, which is this one. But why it is I minus 1? Means it is saying that I'm not drinking this energy drink. I'm just carrying forward whatever energy drink we had earlier. And suppose if we're drinking this energy drink, then I can drink. Else, if I'm not drinking this energy drink, then this will be carry forward. So one will. Now, if I'm drinking this energy drink, I can drink this energy drink also. So 4 plus 1 5. And if I'm not drinking, then if I'm not drinking this energy drink, so whatever maximum was here. If I'm drinking this, I can drink this. If I'm not drinking this, I can move with both forward. If I am drinking this energy drink, I can drink this also. So this plus this. And if I am not drinking this energy drink, then whichever is maximum out of these two will follow up here. But only this is being followed up here. Why? Why is that case? Why is that the case? If I want to drink, if I want to drink this energy drink, I can choose the previous energy drink, or I can choose this energy drink. Sum of both of them will give me a value. Whichever is maximum, I can place it over here. And if I'm drinking this energy drink, I can drink this energy drink, or by skipping this part, I can drink this energy drink. I'm confused. I need a better recursion top down to bottom up. Hey, current drink type is 0, drink 1 or drink 2. Give me 1 minute. There is someone outside. Just a minute. I'll be back. Uh, एक minute. I'll be back. sorry. Iterative with try recursion plus memo. Second approach is the iterative version with optimized space. Drinking. I thought drinking. I thought drinking. J is equals to drinking. I need something more where you can explain me a little more. I see. Is there any follow up over here? It's not written follow up over here, but okay. It can be a follow up. I'm starting from 1 till n. What I'm doing is I'm considering this as an energy drink 1. So if this is an energy drink 1, I'm drinking this energy, and also I'm drinking energy from previous of the same drink, which is being filled over here. And this, if I'm drinking energy drink 2, then this and the same drink from there. So dp of I of 0, dp of I of 1 will be filled with that. That is fine. If I is greater than 0, what now here something which I was thinking of. See, dp of I of 0 is something drinking this energy and the previous energy one. Else if you are not drinking this, so drink this energy and this energy drink of another, this one. Now this is what he is doing, exactly same what I was thinking of. Drink this energy if you want with the previous one, if same, or drink this energy with the second previous one. This will do the job. Correct. Now this is a correct iterative approach. So let's try this with iterative also. Let's try this with iterative. Maybe optimizing space is one of the more possible option, but let's try with taking some space and then we can optimize it more. We have a vector int of dp. dp will be nothing. Make it a and b. A dot size of to everything initialized with. And so Let's remove this. Uh, Starting from 1th position, so for that I need to fill my 0 of 0 with a of 0 and dp of 0 of 1 with b of 1. I is lesser than a. Now there is one thing, dp of I of 0, dp of I of 0 can be updated with drink this, drink drink a of I plus dp of I minus 1 0, and dp of I of 1 is equals to drink b of I plus dp of I minus 1 1. So in this case what I am doing is I'm drinking, if I'm drinking this portion, I can drink the previous one also. So what I'm drinking is I'm drinking the current portion and I'm also drinking the previous one, right? And now if my I is greater than or equals to 2, then dp of I of 0 will be maximum of dp of I of 0, or if I'm drinking this portion with dp of I minus 2 of 1. Because I cannot drink this. Same thing, dp of I of 1 will be maximum of dp of I of 1, or I'm drinking this b of I here plus dp of I minus 2 of 0. And at last I will be returning maximum of dp of I, not I, dp of a dot size minus 1 0 comma dp of a dot size minus 2 minus 1 1. So this is giving me okay. Why? Oh, but this is not what long. Mhm. Oh, wow. Should be of zero now. Okay, great. It's accepted now. So this was tabulation bottom up. Okay, great. So this was also a good question. One of the good question that I would say. We know two way to solve this. Memory optimization is one of the possible way. We can also do memory optimization because we only need two variables, four variables which will help me do all these things. Correct. So I can reduce this to four variables and do the job. Okay. Yes. So suppose I'll take a lunch break now. After maybe I'll reduce it to, I'll take 50 minutes of lunch break and then I'll be back and we'll start again. So I'll be back in 50 minutes. I'm back. Let's start. uh, Thank you, Amangiri. Uh, so we were able to complete this one. So back we find the power of k size array 1 and 2. Okay. Let's try 1 and then we'll go for 2. Maybe that will give me some idea. Actually, in last stream I saw you, Aman. Saw your message, but somehow my internet got disconnected, and I was not able to stream after that. But now it's fine. So just a second. Okay, let's start. So we are given an array of integers nums of length n. So we have been given an array of integer of nums n of length n and a positive integer k. Fine. The power of an array is defined as the maximum element if all of its elements are consecutive and sorted in ascending order. Its maximum element is, yeah, yes, sort of. We got the webcam. It was not working earlier, but I fixed it. You know, I'm an engineer. I fixed it. No, no print start. So its maximum element is all of its element are consecutive and sorted in ascending order, -1 otherwise. Bro, show the engineering degree. Bro, I am masters. Hey Prasoon, how are you? Long time no see, bro. ब्रो पीछे का कूलर चला रखा क्या? नहीं, कूलर तो नहीं चल रखा, फैन चल रहा. आई थिंक इसका नॉइज़ है, थोड़ा तो आ ही रहा होगा. इंजीनियर डिग्री नहीं है, पीजी डिग्री है मेरे पे. We're given an array. The power of an array is defined as its maximum element if all of its elements are consecutive and sorted in ascending order. -1 otherwise. You need to find the power of all subarrays of nums of size k. आज क्रिकेट खेल रहे क्या प्रसून शाम में? रिटर्न इंटीजर, ये कॉन्टेस्ट का क्वेश्चन क्या? कॉन्टेस्ट का क्वेश्चन, आई थिंक कॉन्टेस्ट के क्वेश्चन है शायद रिसेंट के ही हैं, क्योंकि मैं पीछे से सॉर्टेड में पीछे से बना रहा, तो आई थिंक ये सारे क्वेश्चन कॉन्टेस्ट के ही हैं जो भी दिख रहे हैं. Okay, you need to find. Let's see. There are 5 subarray of nums of size 3. 3 के 5 है, 1 2 3 4 and 5. 1 2 3 maximum element 3. 2 3 4 maximum element 4. 3 4 3 whose element are not consecutive, because this is sorted in ascending order. Now so the last element is the maximum. For this is also sorted in ascending order, so the last element is the maximum. This is not sorted in ascending order. Now 4 3 2 is also not sorted. 3 2 5 whose elements are not consecutive. What does that mean? Not consecutive and not sorted. Okay, the elements are consecutive here, 2 3 4, but they are not in sorted order, 2 3 4, something like this. Here the elements is not even consecutive, because 3 3 has been repeated twice, so there is no meaning of sorting here. So maybe this is this looks like a sliding window, where we have a window given over here size of 3, and we just need to make sure that all the elements that are coming in this slide in this window should follow the consecutiveness and ascending order up thing, right? Let's see another example. So window is 3 2, no, 2 3, yes, 2 and 3 is sorted. Then we are removing 2 and then we are adding 3 2. 3 2 is not sorted. Again we are removing 3 and 2 3 is sorted again. For this we are here, and then we are removing 3 and adding 2, which is not sorted. Okay, we need to somehow track the consecutiveness, because sorting can be tracked with the help of some stack or bro, try to solve this question in Java. I can try to solve this question in Java, but I'm not very much comfortable with the data structures that we use in Java. So 3 2 3 2 3 2 3 2. Now how can I approach this? Something is giving me an intuition of using a stack, maybe, or a hash map, maybe a sorted hash map. Yeah, a sorted hash map, or maybe a DQ something. Can we use a DQ? Let's try with DQ. So we have one. It's fine. Now we need something in ascending order. So we'll if we check from front, we keep a DQ. We check from front, and we can also check from back. So checking from front, if the next element that we have is bigger than this element and just bigger than this element, so we are still following the consecutiveness. or a hash map. Which one is a better way? Let's approach with both 1 and 1 with a frequency of 1. I have 2. I can see 2 is greater than 1 and just consecutive. So let's keep it, and keep 2 is also over here with a frequency of 1. Now 3 also is just greater than 2. So 2, 3 with a frequency of 1. Now the window is of size 3 now, which is k, what we have. Now we can see the top element and the bottom element over here. They both will give me the largest value. So we can keep 3 over here. Now picking up the next element will obviously going to remove my last element. The last element is nothing but 1. So if I remove 1, it will be removed. I'm adding a 4 here, which is just greater than 1. So in this case, if I remove 1 and add 4 over here in this DQ, till now it is going fine. 2, 3, 4 till it is going fine. Now if instead of 3 we have 1, now what will happen? Now we remove 2. Now adding 1 from front is telling me that 4, 3, 2, they both are smaller than, they both are greater than this specific value. That means I need to remove all these values, because this needs to be consecutive in increasing order. Obviously our next element is 1, which will eventually remove all these, and 1 will be added in the front. Now array size is not, now array size is something size of 1, which is not giving me an appropriate answer. Maybe 1, 2, 3. So instead, when we are adding 1, we are removing 2. So if we remove 2, we add 1. 1 will go over here with a frequency of 1. Now every time if I'm okay, so the num's length is given me 10 to the power 2, so I can go for n square solution. This is one of the possible way, but in the second one, what is n? Num's length is 10 to the power 5. It's the same question, but num's length is 10 to the power 5, so we need to figure out a single approach. In this case, if we are going for n square approach, then I don't have any problem. Then I think I don't have any problem. I can directly iterate over the window and check the consecutiveness. So that is not going to create a problem. The problem is when we have a array size of 10 to the power 5. Now we need something which will give me an idea on. I need for that case, I don't think DQ is always going to help me. DQ, why if there is no consecutiveness, let's see an example where there is no consecutiveness and how DQ is behaving in that situation. Now we have 1, 2, 4, 6, 7 and 8. In this case, how DQ is behaving, we will have a DQ of something like this. 1, we inserted 2, we are we going to insert 4? Let's add 1 over here also. uh, maybe let's take a better example. 2 3 5 1 2 3. So we have 2 over here. We added 3 because it is consecutive and also increasing order. We added it in the front. Now 5 is not consecutive. Now we know that we don't require these all arrays, these all values, because 5 was not the consecutive one. It was violating the consecutiveness, so we need to flush everything which was there, and we need to start from here. So we need to push 5. Now a value comes which is lesser than 5. Now again we need to flush everything, because it will hamper our consecutiveness and everything. So 1 and then 2 is consecutive, and then 3 is consecutive. Maybe DQ can also help in this situation. Now if we have 2 3 4 5 and 1, so we added 2 in our DQ, we added 3 in our DQ, or even Q, because we are not doing anything from behind, so maybe Q can also give me this answer. So 4 is also there. Now my Q size is in a consecutive way. So now I can write this 4 as our answer for this 2 3 4 4. Now again we need to remove this from behind. Okay, we need to remove from back. So for removing from back, we need a DQ, and we need to push 5. Bro, try to go with brute force. Brute force is very simple, bro. I think you must have understood the brute force approach. Okay, let me explain you the brute force approach. Brute force approach is nothing, just n square complexity. Start with here, take a window of this k size, and iterate over this k to see the consecutiveness and increasing order. Simple. Window of 3, and then start from here, and then go for a window of 3, check for consecutiveness and increasing order, then start from here, check for consecutiveness and order, start from here, consecutiveness and order. Maybe that is not that is what you can understand. It's not that difficult, Prasun. I think in this in this question, which is find the power of k size subarray 1, we can apply the brute force approach, because it is the num's length is 500 only. I'm trying for solving this also. So if I'm able to solve this will obviously going to be solved automatically. So for that I was thinking of going for some brute force approach. So 3 4 5 for this is 5 is my answer. Now 1, the moment I see a value 3 4 5, a value which is something else, I will just flush everything from behind, and I'll add one a new value. I saw 3 which is not consecutive also, so I'll flush it. I'll add 3, and then 4, and then 5. So maybe we can try this approach. Let's see. QUE DQ of integer array. Hmm. So what we need to check something. If our dq dot size is equals to k, so dq dot pop back, because the new element that we will insert should be now. If not dq dot empty, if dq is not empty, do we must be having something to flush the dq, reset the dq, or something, how to reset the deq in C++. dq dot clear, there is a method clear and erase. My dq dot clear. If not dq dot empty, I will check dq dot front, not the back one. So int element, I'll pick element of dq dot front. Now if element plus 1 is equals to nums of I, if not equals to nums of I, that means I need to flush the whole dq. So dq dot clear. So we flushed the whole dq, and after that I can push this dq dot push front. Push front nums of I. Now if dq dot size is equals to k, so I need to create a resultant vector. Just a second, I need to check one more condition. Now if my I, bro, have you checked the time complexity of dq dot clear? Let's see. Its complexity is linear. So it might go n square. No, not n square, but it's supposed to be n into k, nums of length into k, if we are doing something like that. And k can also k in here, k can also go till n. If it is going till n, will it be n square complexity? Will it going to be n square complexity if my k is n? For every element we won't be doing that. I don't think it will go n square complexity if we are using dq dot clear. Let's see. Let's see. If I is greater than equals to k, I is 1. If I is greater than equals to k, what can we do? What can we do? If dq dot size is k, so I'll push result dot push back dq dot front else result dot push back -1, and at last I'll return result. So it's 3 4 -1 -1 second case -1 in third case. So the test cases are passing. Can we think of some test cases which it might fail? Let's add some test cases which I was thinking, 2 3 and 5, and then 1, and then 2, and then 3, and then 4, and then 6. No, let me take k as 1 2 3 4 5 6 7 4, not 3 4. Change k as 4, add one more test case as k as 1, add one more test case in which k is 2, add one more test case in which k is like 8, or even 1 2 3 4 5 6 7 8 8, correct. Okay, let's try. Let's see if we are failing somewhere. Okay, it got accepted here. Let's try the same solution. Result array, results array. Let's try submit it, and let's see if it is throwing me time limit exceeded. Accepted. See, why it got accepted, I'll tell you. Even though the DQ's time complexity is linear, where is it? So the thing is something. Suppose I have an array of size 1 2 3 4 5 6 7 8. We have all the elements in increasing order and an element 1 over here. My k is somehow supposed to be 8, so k is 8. So even my k, if my k is size of n, means 9. If my k is 9, which is size of my array, my iteration will go till here, and then this condition will be true, and then it will check. even this clear will only happen when we are at a place where we are facing some problem. Like here, till 8 everything will be there in my DQ. 4, 5, 6, 7, 8. Till 8 everything will be there in my DQ. Now whenever 1 comes, when 1 will arrive, this hole needs to be flushed. So this hole will be iterated again. That's true for flushing the DQ, right? But this will take what? This is for iterating till here. It is taking O of n time complexity, and this is happening only once. This flush is happening only once. We are not doing it for every element. We are not flushing the whole DQ. Means the whole array of DQ. It's not something like that. That will give us the time complexity of O of n square, but this will not give me the time complexity of O of n square. Every time will flush a size of array. Means the highest complexity that we can go is when we have an array of size 10 to the power 5, array of size 10 to the power 5, and k is 1. If k is 10 to the power 5 only, so until and unless our DQ size reaches to 10 to the power 5, or we face some problem at the end, we will not be flushing the whole array. Here, if our k value is 1, this is the worst scenario that can happen. When our array size is 10 to the power 5, we push the element in our DQ 1, and we popped that element again. So this is taking every time we are doing 2 operations. We are pushing it in our DQ, we are popping it from our DQ. Then we are pushing it in our DQ, and we are popping it from our DQ. Pushing, popping, pushing, popping, pushing, popping. So this might go till O of n plus n, because everything is happening only once. We are not flushing the whole array again. On this element we are not flushing the whole array. In this element we are not flushing the whole array. In this element we are not flushing the whole DQ. Sorry, for every element we are not flushing the whole DQ. Something like that. Are you getting Prasoon? So this is the reason why DQ dot clear can work over here. So actually I was thinking of approaching with hash map or DQ, whichever is going to be more better. But because hash map will sort the array, map will do more complex things. We don't want it will hash, it will place it somewhere else. So for that, DQ will always give me a clear picture what is happening. That's why I use DQ instead of hash map. Yeah. But no problem, Prasan. Thank you for asking the question. It was really nice. And somehow it clicked. I'm not sure that this would have clicked so easily, but it clicked. Maybe we can go to some solution and see what they all are doing. Sliding window solution, easy C++, O1 in space, and 100%. Are we seeing 10 to the power 5? Yes. What in the world are you doing? Valid. Oh, so for first, it's not a good solution. Vote most votes. We count consecutive elements as we go. If the number of consecutive element is greater than or equals to k, then nums of I is the power. Yeah, obviously we could have skipped the DQ part also. We could have skipped the DQ. I don't think DQ was helping me that much. We can do the part that DQ was doing using a variable also. Correct. So this is a better approach, a better way to solve it. To count, else start from 1. If my count is greater than or equals to k, I'll add this number or else -1. Nice. Count the number of good nodes. Let us see this question also. Okay. So we are given there is an undirected tree with n nodes labeled from 0 to n minus 1. Ouch. Just a second. There is an undirected tree with n nodes. Fine, that's fine. Labeled from 0 to n minus 1. And rooted at node 0. Okay, again, there is an undirected tree with n nodes labeled from 0 to n minus 1 and rooted at node 0 and rooted at node 0. Fine. You are given a 2D integer array edges of length n minus 1, where edges I is equals to ai bi indicates that there is an edge between nodes ai and bi in the tree. Fine. A node is good if all the subtree rooted at its children have the same size. What does that mean? A node is good if all the subtree rooted at its children have the same size. A node, if this is a good node, that means if all the subtrees rooted at its children have the same size. All of the nodes of the given tree are good. I need to know where it is bad. There are 6 good nodes in the given tree. They are colored in the image. So this node left subtree and right subtrees are counts are same. For this node, left subtrees count is 1 2 3 and right's count is 1. For this it's 5 1. So for that it is not. In this case, if we see, so one thing that I got intuition from here is always leaf node, leaf node will be in our answer because it's left and right at 0, so it's always same. Zero zero for here. Left is 2, right is 2, left is 1. For this why so here 4, here 4, here 4, so that's why this is selected. And why this is selected? Why these all are selected? So this is selected because it has a left and right as 0 0. It's not a binary tree actually. Okay, why 7 is selected in our answer? Because it has only one. Because there is no other rooted trees. Okay, there is only one path to go as its child. So for that reason this is okay. How we need to track two things. First, number of nodes from wherever branch it is coming to the node where I want it. First thing. Second thing, how many branches does it has? Like from 9, where all I can go? From 9 I can go to 12. From 9 I can go to 10. So there are 2 branches. From here there are 3 branches. So all the branch should have equal number of node for them. From here we also have 3 branches. So for all branches there should be 1. From here we have only one branch. So if there is only one branch, I would say every branch should be. So I need to somehow keep track how many branches are there, and every branch has how many nodes. These are the two things that we need to uh, keep track of. How many for a single node, we need to keep track of two things: how many branches are there, and each branch has how many nodes. Correct. So these are the two things that we extracted from here. And we can work something out. We need to keep it somewhere. We can create a hash map for this. uh, how many branches are there, that will tell me by creating a graph. 0, I can go to 9, I can go to 5, I can go to 1. So there are 3 branches total for 0. Correct. This is telling me. Now every branch has how many nodes? Now 9, including this 9, so I can somehow store it in pairs. Somehow we can store it, if we can store it in pairs. So the next time we can iterate over this and this and check if 9, 5 and 1, everyone is having the same. So we will populate once and we'll use that population next time, in next iteration, to solve the answer, to find the answer, like how many. That will give me the count of the nodes. I think this way we will be able to do it. So maybe we'll keep track somewhere in another hash map. Every node has how many child nodes. Every node has how many child nodes. Every node has how many child nodes. So 0 is going 9, 5 and 1. So 9 has how many child nodes. 5 is having how many. 1 is having how many. So something, it's something kind of a DP storage, what we used to do generally. Okay, okay, fine. We'll be able to solve this question. So let's take a 10 minutes of break, and after the break, we'll be solving this question back. See ya in 10 minutes. back again. Okay, so let's solve this. So what we so the node is always rooted at 0 and rooted at node 0. So it is saying the node is rooted. For that, let us create another map of int comma int, not int comma vector int. This there will be two. One is graph and another unordered map of int comma int count. Now let's make a graph from these edges. So from and to int from edgs edges of I of 0 edges of I of 1. Now this graph will be populated with from dot pushback 2 and g of 2 dot pushback from. Correct. Now populate count. There is a method which will populate our count. This count will take starting node from 0, graph, and our count. So we have populate count. It will return nothing. I don't need. Do we need? Yes, we need. And whatever this populate count populate count will tell me what. How many children are there? So count of 0 is equals to populate count int node I have this graph. I have this count. Okay. Excuse me. Sorry. For int I is equals to 0. I is lesser than g. G of node I need to have a previous node also, so that I should not go to the previous node, which is -1 for this. In previous node, g of node dot size plus new node is equals to g of node of I. Now if this new node is not equals to previous node, children is equals to children plus is equals to g of node populate count new node graph count, and previous node will be this node. From here I'm jumping to here, so this is my new node, and now this becomes my previous node. Now this count of count of node is equals to children plus 1. Now I have this count populated. Now what I will do, I will iterate over this again once more. see, there will always be children. There will always be link of its previous node, which I don't want, which we don't want. Like if you see this one has two branches here and here, but it has one more branch here. But we don't want this. We don't want this above branch. We want only lower branches. So it is rooted at 0, but it's not in a sequence, right? So we'll iterate from here. If it is 0, for 0 we'll take a whole this tree, but for 0, so when I return back to this position 4, now we'll see except this previous node, is there any other branch, and all those branches count are same or not. If it is same, we'll increase our result. It will be something like that. Okay, find answer. We'll start from node 0. We'll have everything. Okay, so we are finding the answer. And we will return result. Maybe I can even declare this as global. Void find answer. We'll have everything. The only thing will change is the logic. And when we are falling back, like suppose we reached 4, and then we are falling back. This can be done in one iteration. This could have been done in one iteration only. So when I'm at 3, so instead of doing this, returning directly, count node has children of 1. Back to this node position. So I'm back to this node position. I know its children are this and this, and these children are already populated because I'm at this position. So I can directly add a for loop here. It'll be same as condition till here this. If it is not same, that means the new node. So in place of this new node, what is the value that is stored? So this new int first if first val is equals to -1, so count a node, not node, new node. So first val is equals to new node. This will be done. If not, else if count of new node is not equals to first val, I need some boolean bool is good is equals to true. Is good is equals to false, and simply break. Now is good is equals to true. Return okay. Oh, okay. These are the two for loops that I can handle. This is good and everything here only. Instead of iterating again, Mm-hmm. Can we? Let's see. I think we can. So it will bring some value from. For this new node, this populate count will return some value, which will be stored over there. Okay. Give me 2 minutes. I'll be back. Okay, so how can we reduce the complexity? This is what we were discussing, right? Because it is giving me time limit exceeded, I need to know how can we reduce it. See, whatever is the total value that is being returned. So there is something that I can do over here. If we see there is a scope, there is some scope for this. So this new node, there is some scope over here. If I can say from this node, whatever we will get, my count of new node will be populated. And children plus is children plus is equals to count of new node. Now this count of new node has some value. Now if I is 0, that means this is the first value that we encountered. If I is equals to 0, this is the first value that we encountered. Now if I is 0, uh, first val, no, not I is 0. If first val is equals to negative 1, then first val will be stored with count of new node. Else, if count of this new node is not equals to first val, no, first val is good, is set to false. if is good is true, result will be increased. Now let us see. This is being passed by address, previous node can also be passed by address. Hey, why we are getting time limit exceeded? Just a second. I'm get from here. I'm going to here. From here, from here I can go to here. From here I was called it till to here. So from here I should not go to. From 1 I can go to 4, I can go to 3, I cannot go to 0. Why I'm getting a time limit exceeded? Obviously. I am iterating over the array only once. 10 to the power 5 and 10 to the power 5. I'm going to each node only once. But why it is giving me time limit exceeded, that I don't know. Is it because of this unordered map? Uh, hmm. Just let's instead of doing this unordered map, let's make it vector to the vector. Vector int graph will be of size edgs dot size plus 1 comma this will also be vector int count of size edges this of this and I need only vector of it. Okay, creating a vector is much more better than creating a map. Always, it's always the case. Now it's accepted. It's because of the map we were facing these issues. Okay, these are something which we need to keep in mind. Like maps are not always going to give me the accurate result or accurate time complexity whatever we want. So instead of that we can keep, if we have a option of keeping an array or something like that, vector array, we should use those instead of these. Okay, so this was also a good question. Not that difficult, I would say, logically, but yeah, it's because of that I was able to reduce it into single for loop. So it's good. It's good. So hopefully we'll be doing some more questions next week. So let's stop here, and I have to do some. I have to go out. I have to have a haircut and all those stuff. So maybe next week we'll be back again, solving more lead code questions, more CP questions. Today we were not able to solve more CP questions, but next time we'll start with CP questions and then we can jump to lead code questions. So it's great to have things to know, things to learn from every question. So grow, learn, and grow. So it was nice solving all these questions. We'll meet next week, probably, and we'll be solving more questions, more and more questions. So thank you for all for joining. Whosoever joined, it's lovely talking to you. Saurabh Shekhar, Prasoon Varsne, Aman Giri. Thank you very much. I will come back next week and we'll solve more questions. I need more from you. I need more input from you guys so that I also get motivated to make more videos like this. So maybe in near future, if everything goes well, I'll be doing some small streams also in the weekdays also. Maybe for 1 hour, 2 hour weekdays stream, and then weekend streams are always there. So it was really good. So thank you everyone for joining in. Hope to see you in the next weekend. Bye bye.